Welcome to Virtual Laboratory. I am Professor Uttam. Today I am showing you how pH control is carried out in a laboratory. You can see there are two tanks. This is a acid solution tank which can be pumped through a control valve, and through a rotameter the flow can be seen, and it falls in the mixing tank where a motor mixes this acid and alkali. The alkali comes from this tank through a pump and another control valve and through a rotameter. So the acid and alkali flow rate can be seen from here, as well as it will be displayed by the recorders. The set point is the desired pH. Here it is shown as 7, desirable. Generally 6 to 9 is required in the industry. So we'll show you here how control can be carried out. Now in addition to that, you will see there is a instrument air compressor to drive these air operated or pneumatic valves, these two pneumatic valves, which are driven with the help of this IP, that is a current to pressure converter, where the compressed air, instrument air, must be free from moisture and particles through the filter, and then enters at a constant pressure, usually at a pressure of 20 psi, that is slightly greater than atmospheric pressure, and I2P converter, which converts the electrical signal into pressure signal in the range of 3 to 15 psi to drive this pneumatic control valve. Both the valves are driven by this IP. This is IP connected with this controller, which produces output current here and is converted to equivalent pressure, which drives this control valve. Similarly, here also the controller produces signal, which produces electrical signal converted to pressure signal and drives this control valve. And here it is a alkali controller and there is a acid controller. Both are connected together in such a way that display will be same. So if you press auto here, both will be active, and then you can see how it is working. Now you start with the automatic system. Say press auto. Before that, you adjust this set point. Say it is your set point is 7. So both the set points are 7 here. You can see. So both the set points are made as 7, and then press auto. Either of this controller is made auto. The compressor is also started. The pneumatic air is supplied and it is passing through I2P converter to drive this control valve. You can see it is trying to maintain 7 at the desired pH, which is a neutral pH. You can see the recorder also and get the plot, and see this is at 0 level, so we can magnify it, say 5 times we magnify it, then plot it. Then you can understand there is straight blue line is a set point, is 35 divided by 7 divided by 5, that is your 7 is the pH, and this red lines are the slight fluctuations of the pH as measured by the controller SPV. Now you can see this is slightly fluctuating, plus minus about 7. We make it 8. So it will try to maintain 8, and after some time it will be 8. The 7.99 is almost 8. Now we record it. You will see the plot as magnified 5 times. So you can see this value is 70 by 5, that is 14. It is gone to maximum alkali and then drops, the alkali drops and then matches with the desired set point. 40, that means 8. Now back, we want to make it as 9. So this is nearly 9, and record it. You will find the record. So here we started new value. So 70 and then jumps down to 45 means divided by 5 is 9. So you get this pH just 5. Now we will go back. There is a wide fluctuation between 6 and 9. We can make it 6 as we want to make it acidic. Alkaline is 9 and now it is acidic. So 6 to 9 we will try. So it is exactly 6. You can see now the plot for the next 100 seconds. So it was 40 by, that is 8. 40 divided by 5, 8. Then alkali, you see the measured value has jumped red because of too much of alkali. Then it is maintained 45, that is 8, and then it drops to 30, that means 6. Now you can see what is the value is 6. So it is maintaining the pH value, and this the paddle mixture which makes the acid alkali well mixed, and it is very difficult to maintain the pH manually. As you see that if you press manual and output of this controller produces signal which completely closes two valves. And now you can open it. Say acid valve is open. It is fully open, and you can see the PV value is 1.33, highly acidic. And then you close it. That is totally closed, totally open. Now you close it, and then you add alkali by opening this valve. Valve is full open around. Say make it so just partially. You try. It will never be achieved because it is quite difficult to adjust this in the manual mode for measurement of pH. As soon as excess acid comes here, there will be a drop in pH towards about 1. And so you can add it, you can quickly see that it is acidic. And then you try closing this. It is still acidic, highly acidic. You try open this alkali valve, slightly increasing, and that will jump very fast. Very difficult to adjust this. So it is better you this coming to 6. Now it is around 6. You can add some more. So this is the maximum we have given, and now at this acid is maximum and alkali is maximum is 6.62. For different steady state conditions will arrive, and different pH will be available. It will cannot be very equal to 7, but it will fluctuate between 6 and 9. So we will go to automatic. You can see that acidic, both are acidic. The slight amount of alkali is being added because already acidic, and then you increase this set point, is alkaline. Then it is 7, suddenly too much of alkali, and then it drops down to 7. So it is fluctuating around 7 plus minus. So it is quite easy with the help of a controller, two controllers which are manipulating the flow rates or acid as well as alkali, which are mixed, and then pH is measured, is found to be controlled near about the set point. There are also tune parameters. You can see the direct acting, proportional band 100, reset value is 0, reset value is 0 and the rate value is 0, that is, it is only P control. This is a direct acting 100, reset value is 1, that means it is PI control, rate value is 0, that means it is 2. Similarly, here also you can tune this acid controller. You can see it's a reverse acting and proportional band 100, reset value is 1. So this is also PI control, rate value is 0 and race is 1. So you can make this automatic and then make this at 0.7. This is auto. So it is maintaining 7 plus minus, very quickly fluctuating. So that's all for this system. Only thing that it is somewhat older system where the pneumatic valves are used. Usually the diaphragm valves are used, maybe motor operated or plunger operated valves, which are used for adding alkali and acid and mixing tank. pH is a pH electrode which measures the pH and produces electrical signal which is accessed by the controllers. Both alkali and acid controllers, they have the same value. This is connected in series, so both are connected and both produces output. This signal goes to the acid valve and this signal goes to alkali valve. I hope you understood this method of pH control system. Thank you very much for watching this video.